So let us imagine this is your house, okay? And here is a room, here is a room, here is a hall, here is a room, here is a room, and again here is a room. Let me say this is your room, this is your father's, this is your mother's, this is your sister's, and let's say you have a pet and your pet has a room as well, and this is a common hall, okay? And this is a scenario which I'm going to use to explain all the types of AI agents that is in the world right now. Okay. And let's say you bought a new machine, new AI agent to clean your room. Okay. And that agent looks like this. This is an automated AI agent that cleans your house automatically. No manual work needed. Okay. So before diving deep into the scenario, I want to say that there are a total of 5 types of AI agents. Okay, let me name them one and explain, give the explanation, and then move on to the next one. Okay, so the first AI agent, it is called simple reflex agent. The name itself suggests, right? It is simple and it's a reflexive agent. What does it mean? Let's see here. Simply, let me see, this is the type 1 agent, and it is a simple reflex agent, and I say the agent that, hey buddy, if a room is dirty, go clean. That is it. It's like an if or else statement. If you see the room is dirty, go clean. If room dirty, clean. That's it. The AI agent first looks your father's room. If it is dirty, it will start cleaning. And likewise, it will come to your room, your mom's, your hall, your mom's, your pets, your sisters. That looks good, right? But the thing is, your the first type of agent, that is simple reflex agent, does not have any memory. So once it cleans your sister's room, you don't know what to do again. It just wanders again to your pet's room, which is already clean. Okay, it will see the room is clean, so go to your mom's. It is also clean. Go to your hall. It also looks clean because it just cleaned your hall back, right? Then checks your room, then check your father's again. The disadvantage of the first AI agent, simple reflex agent, is it has no memory, so it keeps up looping again, and that is a disadvantage. Let us see a small theory part. Okay, the first agent which I said is that, as I said, it's simple reflex agent. Definition: acts only on the current situation using condition action rules, which is, I said, right, it will be programmed a specific condition. If the room is clean, if the room is dirty, go clean. So yeah, the things work like that. And it has some key points, like it has no memory, it has no internal state, no history, it does no planning. Like everything is fed. It just follow the rules given already. Now let's move on to the next type of AI agent. And now our AI agent got an upgrade, and it is called model based agent. It is almost similar to the previous agent we talked before, but it has only one change. It has memory now. So what it does, eventually, it first checks your father's room, checks if your father's room is clean. If it is clean, it won't clean. If it is dirty, it will clean your father's room, and it will add it to the memory. It will add to the memory that this room is clean now, so I don't have to check it again for at least a few hours from now. Clear? Then it will check your room. Then it will check your room, hall, mothers, pets, sisters, and so on. And the thing is, after every room is cleaned, every room is visited, it won't check the other room which was previously cleaned before. So it is a save of energy, saving of time, and it is a slightly improved version of the older AI agent. Clear? Okay. So let's see the theory part of the second agent. It is called model based reflex agent. Definition: uses the current condition plus an internal model of the world to decide actions, right? First, it cleaned my father's room. At last, it cleaned my sister's room, and then it won't go again check my father's room, right? Because it cleaned already, and it just stored the memory that I have already cleaned this room, so I don't want to go again. It eventually saves a lot of time and energy consumption. This is basically part 2, and it is called model based agent. Now let's see the type 3 of the AI agent called goal based agent. Just with the name we can understand the definition, right? A specific goal is given to that agent, and we expect that agent to do that work. And it looks like even the first agent, that simple reflex agent, does the same. We gave a rule, we gave a condition, but it all sounds similar. How it is getting differed? Let me explain. We say that if this is our agent, and we say that, hey buddy, I don't want the entire house to be clean. I bought you, so you just do work for me. That is, you work clean my room alone. This is what I am saying to the bot. Okay, so the bot understands and cleans my room, and as well, I am also saying that take the shortest path. Let's say if I want my sister's room to be clean, okay, and let's say there is a path. There is another path to go to sister's room like this, and there are two ways to go to my sister's room from my room, okay? And I'm saying the agent to take the shortest path from my room to my sister's room and go clean her room, okay? This is the goal I'm giving. So there are two conditions: go clean my sister's room and then take the shortest path. So the agent here will analyze where my sister's room is. So it will know that my sister's room is here, and it will analyze which route is the shortest path. The path A is shortest or path B is shortest. It comes to a conclusion that it looks that path A is the shortest, so it takes this route and go cleans my sister's room. Okay, this is goal-based agent. Let us see a theoretical explanation. Goal-based explanation. Goal-based agent. A definition: chooses action that help achieve a specific goal. Key points: has explicit goal. Explicit goal. What is the explicit goal mentioned before is go clean my sister's room. Considers future state, user search and planning. It plans like which route to take, which is the shortest route, which was like a part of the goal. Decision basis, which action leads closer to the goal. Common algorithms is BFS, DFS. Example, navigation system, finding a route to destination. These are all real-time usage. And yeah, let's move on to the next type of AI agent, which is slightly more advanced than goal-based agent. Is called utility-based agent. Utility-based agent is like, how to say is, it is more advanced. How it is more advanced? Let me explain. So as I said, this is the house, and to go to my sister's room, this is the shortest path, okay? And here is another route to go to my sister's room. So there are two paths to go to my sister's room from my room, okay? And the goal is the same: go clean my sister's room and take the shortest path. And here is the twist. Let me say that my mom has put out old furnitures midway of our house, so the path towards my room and my sister's room is blocked. So now my agent cannot take the shortest path to reach because the agent has no way to go to my sister's room. Here is the key: if I'm using a goal-based agent, what my goal-based agent will do is analyze where my sister's room is. So sister's room is here, so it will know and checks which path to take to which path is the shortest route to my sister's room, and it will know that the path A is the shortest and path B is more long, so it decides to take the path A, even if it sees that there is no way, there are furniture blocking the way. It chooses the path A and waits until the path is cleared to go to the sister's room, because the only goal it has is to take the shortest path. Whereas in utility-based condition, even though the condition is like go to sister's room and clean, it checks all the parts available. And when it sees that there is something messy and I think that I cannot go through it to my sister's room, and since it see a blockage, it takes path B, the better option, to go to the sister's room and clean it. This is what utility-based agent is. So let us see the theory part. Utility-based agent definition chooses actions that minimize a utility function. Key point, multiple possible outcomes. It can choose any path that the agent decides this is the most efficient way to do a goal. Handles trade-offs, optimizes overall performance. Utility may represent profit, safety, comfort, efficiency, and satisfaction. Since the utility-based agent chooses the wise decision, everything, the output, the quality of the work, and everything is improved than the goal-based, and thus utility is more advanced and complex than goal-based agent. And at last, we will see about learning agent. Learning agent is, as the name says, the learning agent is like an agent that can learn from its past mistakes. It does not need explicit teaching every time to learn. It itself learns from its past mistakes and improves its performance. For example, learning agent improves performance over time by learning from experience. Key components: performance element, learning element, critic, problem generator. Key points: learns from feedback, adapts automatically, can combine with other agent types. Example is recommendation system, improving suggestions over time. When we watch a specific genre of movies, our suggestion will also be related to that genre of movies. And for a period of time, when we change the genre of movies entirely, our suggestions also keep changing. And that is because the algorithm is viewing our data and learns that our interests have changed, and thus it recommends movies according to our taste. So this is learning based agent.